Hello, students. Good afternoon, everyone. Good afternoon, students. Welcome. Welcome. How are you, students? How are you, everyone? Let me know quickly in the chat box, everyone, so that my audio is clear or not and the screen is visible or not. Quickly, let me know in the chat box, everyone. How are you? Yes. Hello. Good afternoon, everyone. Good afternoon. Let me know, students, so that I can start with today's topic. So today we are going to study. So in the last class we were discussing about the different form of tangent, right? We saw the parametric form. If the point is lying on the circle, then how to write the equation of tangent, right? Those all things we saw in the last class, right? So in today's class, what we are going to do is, first of all, I will just solve one question from the homework that I gave you just for the recall test, just as a recall, and then we will continue with the equation of tangent, and then we will look into the equation of normal and chord of contact. Okay. So shall we begin? Okay. Very good. So let's start. So student, in the last class, one of before in the last class we were discussing about if the point x1 comma y1, if the point x1 comma y1 is lying on the curve, second degree curve, then the equation of tangent can be obtained by using these transformation. Yes or no? Replace x square with x1, replace y square with y1, replace 2x with x plus x1, 2y with y plus y1, and 2xy को xy1 plus yx1, and the constant will not change, right? Yes or no? So everybody remember this, right? So remember, the point should be lie on the curve, on the second degree curve only. Okay. So now quickly tell me, find the equation of tangent at the origin to the circle x square plus y square minus 4x minus 10y equal to 0. So equation of tangent at origin, right? So first of all, what is the circle? Circle is x square plus y square minus 4x minus 10y is equal to 0. I gave you this in your homework, right? So if you have to just draw the rough sketch of the circle, circle has the center minus half coefficient of x, which is 2, comma minus half coefficient of y, which is 5. So 2 comma 5 is the center. Yes or no? Right? So if I now tell me how you will write. Now check 0 comma 0, put 0 comma 0 in equation 1. This is equation 1. So it is clearly, if you put 0 comma 0, it is satisfying the equation. Yes or no? So it implies 0 comma 0 is lying on circle, right? So let's say maybe this is the point 0 comma 0. So equation of tangent, how you can write? So equation of tangent is replace x with xx1. So x square को replace कर दो xx1 से. So x into x1, which is 0 comma 0, plus y square is replaced with y1. So y into y1 minus 4x. So take 2 common. So now you are left with 2x. So 2x can be replaced with x plus x1. So x plus x1. Similarly, take 5 common. So minus 5. So now it's and now we are left with 2y. So 2y can be replaced with y plus y1 constant as it is equal to 0. So this is 0, this is 0. So this is nothing but 2x minus 5y is equal to 0. So 2x plus 5y is equal to 0 is the equation of tangent. This is the answer. Clear? Is this clear? So please, this is very important. This transformation is very important because they can save you a lot time during the exam if you know directly which transformation you have to use. If the point is lying on the circle, then easily you can get the equation of tangent. Okay. Is this clear? Is there any doubt? Okay, very good, very good. So if it is clear, then let's proceed, everyone. So now let's talk about the equation of tangent on circle x square plus y square is equal to a square in slope form. Okay, let's say we are going to find a condition Okay, we are going to find a condition that y is equal to mx plus c is tangent to the circle x square plus y square is equal to a square. Okay, let's say this is a tangent. This is a tangent. Y is equal to mx plus c. Okay, so we just assume that slope is given. Slope is given. Okay, slope is given. Okay, slope m is given. Okay, so now what should be the condition that y is equal to mx plus c line is a tangent to the circle x square plus y square is equal to a square. Okay, so first of all, everyone, in the last class we discussed this in a great length that for any line to be a tangent on a circle, it simply means the perpendicular distance from a center on a line should be equal to radius of circle, right? So P is equal to R. Yes or no? P is equal to R, right? P is the perpendicular distance. So let's say this is the center of this circle is 0, 0, right? So if I drop a perpendicular, okay, if I draw a perpendicular, okay, and this one also everybody should remember that whenever you drop a perpendicular from a center, okay, or whenever you are drawing whenever you are dropping a perpendicular from a center on the tangent, so that foot of perpendicular is always lie on the circle only. Okay, so let's say this is the point P, so this point P is always lie on the circle. Okay, I will just write it down in the separate notes. Okay, don't worry about it. So now perpendicular distance, so it implies perpendicular distance distance from center क्या है 0, 0 on line, let's say mx minus y plus c is equal to 0 is equals to radius, right? Is equal to radius, which is a, right? So in this case the radius is a, so what would be the distance? So perpendicular distance is ax1 plus by1 plus c upon under root of a square plus b square. So similarly put 0, 0 in the equation of line. So 0 minus 0 plus c upon under root of coefficient of x square plus coefficient of y square should be equal to radius a, right? Yes or no? So it implies mod c upon under root of 1 plus m square should be equal to a only. It implies what should be the mod c? Mod c should be a times under root of 1 plus m square. So it implies c is equal to plus or minus a times under root of 1 plus m square. Is this clear, everyone? Is this clear? So this is a condition. So this is known as, you can say, the condition of tangency. Okay, this is known as condition of tangency. Condition of tangency. That is condition for line y is equal to mx plus c to be a tangent on circle x square plus y square is equal to a square. Clear? So for any line of a given slope m to be a tangent on a circle x square plus y square is equal to a square, so c should be equal to plus minus a times under root of 1 plus m square. Okay, so it implies, you can say that equation of tangent क्या आ गई फिर? Equation of tangent is y is equal to mx plus minus under root of plus minus a time under root of 1 plus m square. Clear? Plus minus a time under root of 1 plus m square. Is this clear, everyone? Is this clear? Is this clear? Tell me quickly in the chat box. Is this clear? So as you can see, we are getting a two tangent, right? We are getting a two tangent of a slope m on a circle, right? Yes or no? So it implies there exist two tangent of a slope m on circle x square plus y square is equal to a square, right? And those tangents are y is equal to mx plus a times under root of 1 plus m square, and y is equal to mx minus a times under root of 1 plus m square. Is this clear? Is this clear, everyone? So it implies for any circle, okay, this is just for the, we just derive this equation of tangency for the special circle which has the origin 0, 0 and radius a, and we here notice that for any slope m, there exists such two tangent on a circle. Okay, is this clear? Is this clear? So that's why this is a very important condition. C is equal to plus minus a time under root of 1 plus m square. Okay, so this is very important. Everyone should remember this condition of tangency. This condition of tangency I am going to derive again in the parabola, again in the ellipse, again in the hyperbola. Okay, so everybody should remember that for a standard circle, that is x square plus y square is equal to a square, के लिए condition for mx is equal y is equal to mx plus c to be a tangent is that c should be equal to plus minus under root of a square plus m square. Is this clear, everyone? Is this clear? Tell me quickly in the chat box, is this clear? Do you have any doubt in this? Do you have any doubts? Okay, so if I just give you the slope of the tangent, you can directly write the equation for the circle x square plus y square is equal to a square, right? If I give you the slope of the tangent, then you can directly write down the equation of the tangent if the circle is in the form of x square plus y square is equal to a square. Okay, so let's continue here. Okay, let's continue. Yes, good afternoon. Good afternoon. So let's say, okay, so student, let's say this is one of the question that find the equation of tangent to the circle x square plus y square is equal to 4, which are perpendicular to 12x minus 5y plus 9 is equal to 0. So it means you have to find the equation of tangent on this circle whose slope is the perpendicular to the line of this. Okay, means this line slope, this line L is 12x minus 5y plus 9 is equal to 0, right? Yes or no? Yes or no? So let slope of tangent, slope of required tangent is equal to m. So clearly the slope of L kitna aa gaya? Slope of this line L is minus coefficient of x upon coefficient of y, which is 12 by 5. And these two lines are perpendicular. These two lines are perpendicular. So it implies ml into m. Let's say slope of tangent is mt. ml into mt should be minus 1. Product of slope should be minus 1 if the two lines are perpendicular. So 12 by 5 into mt is minus 1. So slope of tangent kitna aa gaya? Minus 5 by 12. Is this clear? Slope of tangent is minus 5 by 12. So minus 5 by 12. This is the slope of tangent. Okay. So now for this line, for a line to be having this slope, so we can now directly write the equation of the tangent. Yes or no? Right? So equation of tangent with slope m on circle x square plus y square is equal to 4 is y is equal to mx, sorry, x square plus y square is equal to a square for general. Okay, for general circle is equal to a square is y is equal to mx plus minus a times under root of 1 plus m square. And from this example, what is x square plus y square is equal to 4? So our circle is x square plus y square is equal to 4. So it implies a is nothing but 2, right? And slope, and the slope of tangent is 5 minus 5 by 12. So minus 5 by 12. So it implies equation of tangent कितना आ गया फिर? Equation of tangent is y is equal to mx, m times x plus minus a under root 1 plus m square. So minus 5 by 12 का whole square. So this is y is equal to nothing but minus 5x by 12 plus minus 2 times under root of 1 plus 25 upon 144, right? So this is nothing but y is equal to minus 5x upon 12 plus minus under root. Take the LCM. So 144 plus 25, which is 169 upon 144, and 2 it outside, right? So it is y is equal to minus 5x plus 12 plus minus 2 times, इसका square root कितना आ गया? 13 by 12. So 12x is equal to minus 5x plus minus 26. Okay. So equation of tangent क्या आ गया? Equation tangent आ गई 5x plus 12y is equal to 26 and 5x plus 12y is equal to minus 26. So these two are the tangent. Is this clear? So it implies, so clearly we can see that there are two tangents, okay, with the slope minus 5 by 12. Is this clear, students? Is this clear? So if we just know the slope of tangent and the circle is in the standard form, okay, circle should be in the standard form. Standard form से मेरा क्या मतलब है? Center should be, center of circle should be origin. Then directly we can write the equation of tangent of slope m, y is equal to mx plus minus a times under root a plus minus a times under root 1 plus m square. Is this clear, everyone? Tell me, do you have any doubt in this question? Let me know, students, do you have any doubt in this question? Any doubt? Clear? So shall we proceed further? Shall we proceed? Okay, sure. So now, students, so far whatever the equation of the tangent we have seen, right? So whether in the parametric form, whether in the point form, if the point is lying on the circle, right? So in all those situations, the point is always lying on the circle, right? But now we are going to see what if the point is not lying on the circle. Point is always outside the circle. Okay. So let's see. If point P lies outside of circle, that is, if point P, that is, let's say, for example, let me just call this point P. Okay, this point P is x1 comma y1. So this point P is external. Then to find the equation of tangent to the circle, x square plus y square plus 2gx plus 2f5 plus c equal to 0. So center of the circle is, let's say this is C, right? This is C. Center of the circle is minus g comma minus f. Okay. So tell me, students. So student, there are just certain steps that you should always follow. Okay. We are going to use these steps only every time whenever the whenever the point is lying outside the circle and we are required to find the equation of tangent passing through this point P. Okay. What you do? It's very simple. So let slope of, this is the first step. Okay, just let me down quickly. I just write down in the step by step, so there should be no confusion regarding this. Okay, so step 1 क्या होगा? Always let equation of required tangent is m. So हमने क्या माना? Let equation of tangent is, let equation of required, sorry, equation of the slope of required tangent. Okay, let equation of slope of required tangent. Okay, so let equation, so let, one second. So what is the first step, student? First step होगा हमेशा let slope of the equation, let slope of the tangent, let slope of the tangent passing out, passing point P is M. So हमेशा मानना है कि let a slope is M. Okay, so let's say this is a slope M. Okay, we will again prove it. As you can see from the diagram, there will be such two tangents which are passing through this point P. We will prove it. Okay, don't worry about it. There will always two tangents come. Then second step is step 2 क्या होगा? We have assumed that the slope of tangent is M. So now write down the equation of tangent. Write down the equation of tangent. Okay, कैसे लिखोगे? काफी सिंपल है. Tangent is having slope M and passing through the point x1, y1. So equation of any line which is passing through the slope, which are having slope M and passing through the point x1, y1 is y minus y1 is equal to slope x minus x1. Right? Let's call this equation 1. So what should be the next step? What should be the next step? So step 3. This is we have done so many times. For any line to be a tangent on a circle, what should be the possibility? That perpendicular distance from the center on a line should be equal to the radius of the circle. Simple. Now, for equation 1 to be a tangent on given circle, perpendicular distance from center to line should be equal to equals to radius. Is this clear, everyone? These steps are clear. Every time we are going to do this only. Is this clear? So if you have to find the equation of a tangent that is passing through the point P, but point P is lying outside the circle, then now this time point P is not lying inside on the circle. अगर circle पे lie कर रहा होता तो तब तो transformation use कर लेते. But this time point P is lying outside the circle. So what we will do? Let slope of tangent is M. So now any line, whatever, if it is a tangent, doesn't matter. So any line which has the slope M passing through the point x1, y1 should be written as in the point slope form. Y minus y1 is equal to slope x minus x1. Now, ये तो कोई सी भी line हो सकती है ना. So what should be the condition for this line to be the tangent? Simply the perpendicular distance from center on this line is should be equal to the radius. Yes or no? That's all. So line क्या है? Line is y minus y1 is equal to slope x minus x1. So it is nothing but mx minus y plus y1 minus mx1 is equal to 0. Okay, is this clear? So now perpendicular P should be equal to R. Perpendicular distance, now perpendicular distance from center on this line should be equal to radius. So what is the center? Center is minus g comma minus f. So what is perpendicular distance? M time minus g minus time minus f plus y1 minus mx1 upon under root of 1 plus m square should be equal to the radius. Okay, as you can see, student, very clearly that you are seeing a quadratic in M, right? So it is nothing but mod minus mg plus f plus y1 minus mx1 is equal to r times under root of 1 plus m square. Now squaring both sides. So you will see that minus mg minus mx1 plus y1 minus plus y1 plus f का whole square is equal to r square 1 plus m square. Yes or no? So this equation is quadratic in M. Clearly m square दिख रहा है. यहाँ से कुछ इसको स्क्वायर करोगे 2m आएगा, right? So this equation is quadratic in m, right? Degree 2 equation in m, right? So it implies we will get two slopes. So hence we will going to get the two tangent. Yes or no? Right? So hence two tangents are possible from point P, which is x1 comma y1. Point P lie outside of circle, from point P which lies outside of circle, right? Two tangents are possible from point P on circle. Is this clear, everyone? Student, tell me quickly in the chat box. Is this clear? So if the point is lying outside the circle, then it is very clear that two tangent should be drawn from that point on a circle. And from the symmetricity also you can say that ना, from the symmetricity that if एक tangent अगर ऊपर की तरफ आएगी तो दूसरी tangent down side आएगी. Yes or no? So from the symmetricity also you can comment that there will be two tangent. Okay, is that clear, everyone? Is that clear? So this is very important point. Okay, if the point P is lying outside the circle, then the two tangents are possible, right? If the point P is lying on the circle, then only one tangent is possible. Yes or no? Is this clear? Is there any doubt, students? Is there any doubt? So if the point P is lying outside, so now we can easily able to find the equation of tangent. Yes or no? This देखो x1, y1, g, f, these all things we know already, right? These things are known. R is also known, radius, right? So only thing which is unknown is m. So we will make the quadratic in m, then we'll solve the quadratic and we'll get the slope, right? Slope आ गया. So again put that slope in this equation 1, you will get the tangent. Okay, is that clear, everyone? Tell me quickly in the chat box. Janvi Balari, Janvi Chitra Durga, everyone tell me in the chat box. Is this clear? Clear? Okay, okay, very good, very good, very good. So this is one point you should always remember: number of tangent to a circle from a point. Position of point क्या है? If the point is lying outside the circle, two real and distinct tangent can be drawn. Okay, if point lie on the circle only, so point P is lying on the circle, then one real tangent can be drawn. And if the point P is lying inside the circle, then there should be no tangent. Yes or no? अगर कोई point यहाँ पे lie कर रहा है inside the circle, so how you are going to draw a tangent? There is not possible. Yes or no? Not possible. So that's why no real tangent is drawn. Is this clear, everyone? This note is clear. So if somebody have to comment on the number of tangent, just seeing the location of the position of the point with respect to circle, they can comment on it, right? If the point is lying outside the circle, then two real and distinct tangent is drawn. If the point P is lying on the circle, only one real tangent is drawn. If the point P is lying inside the circle, no real tangent can be drawn. Okay, am I clear? Okay, very good, very good. So now let's solve some questions on the basis of this. So one question is this: find the equation of tangent drawn to the circle x square plus y square is equal to 8 from point 4, 0. Okay. Also find point of contact. Now the question is कह रहा है कि first find the equation of tangent from this point on the circle, and whatever the tangent you are getting, so also find the point of contact of that tangent with the circle. Okay. For example, this is a circle that has the center 0, 0 and radius under root 8. So let's say this is circle, this is the required circle. Okay, let's say this is the circle. Okay, so radius कितना है? root 2, 0. So ये distance कितना है? 2, sorry, distance 2 root 2. So this is 2 root 2, 0. Center is 0, 0 and the point is 4, 0. So this is the point 4, 0. Clear? So how you are going to find the equation of tangent? Clearly the point P, clearly point P is lying outside of circle, outside of circle. और अगर किसी को इसमें भी confusion है why the point P is lying outside the circle, they can also do by just put the point P in the circle. Okay, so for example, S क्या है, x square plus y square minus 8 is equal to 0 and point P is 4,0. What is S1? Put the point in the circle. S1 is 4 square plus 0 square minus 8, which is greater than 0. So it implies S1 is greater than 0. So point P is lying outside of circle, lying outside of circle. Is that clear, everyone? Is that clear? Okay. So, but now our aim is to find the equation of tangent passing through this point P on the circle. So that is very simple, right? अभी हमने देखा है, हमें तो डायरेक्ट प्रोसीजर पता है, right? So step 1 क्या है? Let equation of tangent, sorry, let slope of tangent, okay? Let slope of tangent, let slope of tangent m. Okay, so it implies equation of tangent can be written as, equation of tangent can be written as, tangent is passing through the point 4, 0, right? So this is something like this situation is happening. So let's say one of the tangent is this, and let's say another tangent is this. Okay, okay. तो हम तो बस स्लोप m मान लेंगे, अपने आप दो स्लोप निकल के आ जाएंगे, है ना? अगर दो टेंजेंट बन रही होगी तो अपने आप दो स्लोप निकल के आ जाएंगे. ओके, सो इक्वेशन ऑफ टेंजेंट इज y minus y1 is equal to slope x minus x1. yes or no? y minus y1 is equal to slope x minus x1 and x1 y1 are 4, 0, right? कितना आ गया? mx minus y minus 4m is equal to 0. So this is the equation of tangent. Okay, now for line in equation 1 to be tangent, P is equal to R. So perpendicular, what is the center? Center is 0, 0. So perpendicular distance from 0, 0 on this line L, which is the equation 1, should be equal to radius. So what is 0 minus 4m upon under root of 1 plus m square should be equal to the radius. What is the radius? Radius is nothing but 2 root 2. Radius is nothing but 2 root 2, right? तो कितना आ रहा है ये? Mod of 4m upon under root of 1 plus m square is equal to 2 root 2. So now squaring on both sides. Squaring both sides. Okay, so what you will get? 16m square upon 1 plus m square is equal to 2 root 2 का whole square. So it implies 16m square is equal to 8 times 1 plus m square. So it is 16m square is equal to 8 plus 8m square. तो यहाँ से कितना आ गया? 8m square is equal to 8. So it implies m is nothing but plus minus 1. So it implies there are two tangent possible. One of the tangent have the slope 1 and another tangent will have the slope minus 1. Is this clear, student? Is this clear? Is there any doubt with this question? Okay. So how you will going to find? So now what you will go? What you will do is, so equation of tangent is, equation of tangent कितना आ जाएगा? One of the tangent will have the slope 1. So y minus y1 is equal to slope x minus x1, and another tangent will have the slope minus 1. So y minus 0 is equal to slope x minus 4. तो यहाँ से आ गया y is equal to x minus 4 and यहाँ से आ गया y is equal to minus x plus 4. So it implies equation of tangent are x minus y minus 4 is equal to 0 or x plus y is equal to 4. So these are the two equations of tangent. Okay. Okay. So these two are the equation of tangent. Is this clear? Is this clear? Everyone tell me quickly. This is with slope -1, tangent with slope 1. Is this clear, everyone? Tell me quickly in the chat box. How many of you understood this question? Okay. Now we have to find the point of contact also. Okay. So let's say, so see now this is a very important point. Now let's say this tangent are touching our circle at point, let's say A, and this point B. Okay. Let's say point A is x1 comma y1 and point B is x2 comma y2. So if I ask you which one of these tangent is corresponding to point A and corresponding to point B. So first of all, let me write this down again. So let's say this is my circle. Let's say this is my circle. Okay. So one of the slope is 1 and another slope is -1, right? So let's say like this. Okay. So let's say this is the point B, this is the point A, and this is the point 4, 0. Okay. This is the point 4, 0. Is this clear, students? Okay. So clearly you can say that this line will have the slope. This line is making obtuse angle, so this line will have slope -1, and this line is making acute angle. Yes or no? So this line will have slope 1. Clear? Is this clear? Okay. If it is clear, student, then you can say that this line, let's say this is the point P. So equation of PA is nothing but corresponding to slope 1, -1, corresponding to slope -1, right? Which is x plus y is equal to 4. Okay. X plus y is equal to 4. x2 comma y2. But equation of tangent from point x1 comma y1 lying on circle x square plus y square is equal to 8 can be given as x1 plus y1 is equal to 8. Yes or no? Tell me quickly in the chat box. Yes or no? Right? But if the point is lying on the circle, then the equation of tangent can be written in the point form using the transformation x1 plus y1 is equal to 8. Right? So this equation, let's say this is equation A and this is equation B. So equation A and B are corresponding to the same tangent. Yes or no? So equation A and equation B are identical equation, right? So it implies coefficient of x, ratio of x, coefficient of x ka ratio is equal to coefficient of y ka ratio is equal to constant, right? It implies 1 upon x1 is equal to, yahan se coefficient of y ka ratio kya hai 1, from here coefficient of y is y1 equal to, what is the constant term here? 4. What is the constant term here? 8. From here you can say that x1 is equal to 2, x2 is equal to 2. So point A kitna aa gaya? 2, 2. Is this clear, students? Point A is 2, 2. Is there any doubt? Okay. See, using from the external point, first we find the tangent. Okay. Now we got the tangent, but if somebody is asking us to find the point of contact, it means where this tangent is touching the circle, right? So if the tangent is touching the circle, so let's say that point is x1 comma y1. So now let's say x1 comma y1 is that point. So using the transformation, write the equation, and now this equation of the tangent and the tangent equation that we have already found should be identical. So that's why ratio of the coefficient of x, y and constant should be equal. Okay. Now, similarly, you can find the point of contact for B also, right? Now, equation of PB. Equation of PB is what? Equation of PB is the equation of tangent corresponding to the slope 1. So equation of tangent with the slope 1 is x minus y minus 4 equal to 0. X minus y minus 4 is equal to 0. So equation of tangent from point x1 comma y1 from us lying on circle x square plus y square is equal to 8 can be given as x1 plus y1 is equal to 8. Yes or no? Yes or no? So let's say this is equation C and this is equation D, right? So equation, it implies equation C and equation D are identical, right? So it implies ratio of the coefficients should be equal. So coefficient of x here is 1 upon coefficient of x in the equation D is x1 is equal to coefficient of x here is minus 1. Sorry, coefficient of y is minus 1 upon here coefficient of y is y1. So now make sure your coefficient, your constant term should be on the same side, either on the left side or on the right side. So let's say this equation can be written as x1 plus y1 minus 8 is equal to 0. So this is equal to minus 4 upon minus 8. So you can say that from here x1 kitna aa gaya? When you compare these two, how much is the x1? X1 is the 2 and y1 is, compare these two, y1 is minus 2. So the point B is 2 comma minus 2. Is this clear, students? Students, is this clear? Tell me quickly in the chat box, right? Is there any doubt with this? Is there any doubt with this? So if the point is lying outside the circle and they ask you to find the point of contact, okay, so this is one of the method to find the point of contact. Okay, first assume that point is lying on the circle, then write the equation using the transformation form, and then compare this equation with the equation that you have already found. That's all. Okay, so now let's move on to the next topic. Okay, yes, so now let's talk about the normal. Normal is very simple. Okay, जैसे tangent, normal का मतलब क्या होता है? नॉर्मल का मतलब क्या होता है? कोई बताएगा मुझे? If I ask you what is the normal? Okay, इक्वेशन पे तो बाद में आएंगे, पहले डेफिनेशन बताएगा कोई? What is normal? Normal is nothing but, see, line which is perpendicular to tangent at the point of tangency. That means, let's say from a point P I have drawn a tangent. Okay, so a line which is from a point of tangency. Okay, from a point of tangency, at the point of tangency. So let's say from a point P which is x1 comma y1 I have drawn a tangent. Okay, that is not for this circle, that is for any curve. Okay, any curve. Okay, how you going to find the normal at this point is nothing but first find the tangent, slope of tangent at this point P. Okay, then the normal is nothing but a line which is perpendicular to the tangent, but it is passing through the point of tangency also. Okay, so slope of normal पता चल जाएगा, slope of normal पता है. Okay, so slope of tangent पता है. Let's say slope of tangent is mt. So what would be the slope of normal? Slope of normal would be negative reciprocal of slope of tangent only, right? So point पता है, स्लोप पता है, इक्वेशन ऑफ टेंजेंट आ जाएगी, यस और नो, यस और नो, सॉरी इक्वेशन ऑफ नॉर्मल आ जाएगी, यस और नो, टेल मी क्विकली. ओके, सो equation of normal is, so there is one point with respect to the circle that you should notice is normal to the circle, normal to the circle always passes through the center of the circle. Okay, this is a very important point for the circle. Okay, any normal, let me write this down. Okay, any normal to the circle, any circle, so it in this case let's assume general circle, x square plus y square plus 2gx plus 2fy plus c is equal to 0. Any normal to the circle will always passes through the center of circle, passes through the center of circle. Okay, that you should always remember. Okay, that you should always remember that any circle, if I'm just drawing a normal to the circle, okay, so that normal will always passes through the center of that circle. Is that clear, everyone? Is that clear? Okay, so now from this diagram you can say that this PC is nothing but the normal only, yes or no? This PC is nothing but normal only, right? So it implies PC is normal, right? So slope of PC कितना आ गया, which is slope of normal कितना आ गया, at point x1 comma y1 is y1 minus this point upon x1 minus this point. So slope of normal is y1 plus f upon x1 plus g. Okay, so equation of normal is slope पता है, point पता है, point is nothing but x1 comma y1. So point is y minus y1 is equal to slope, which is y1 plus f upon x1 plus g into x minus x. Is this clear, student? Normal समझ में आया? Normal क्या होता है, right? So normal is, let's say for at any point P, you draw a tangent to the circle. Okay. Now, any line which is perpendicular to the tangent and also passes through the point of that point of contact, that is x1 comma y1. So that particular line will known as normal to the circle. Okay, and that normal will always passes through the center of circle. Always, no matter what, that normal will always pass through the center of circle. Okay, if a line which is perpendicular to the tangent of circle and also passes through the center of the circle is always, you can say that is a normal. Clear? Is there any doubt, student? Is there any doubt? Tell me quickly in the chat box. Tell me. Okay. Okay. So normal समझ में आ गया? Okay. So now let's say I have to find the equation of normal of slope 4/3 to the circle x square plus y square is equal to 9. Okay. Question is, find the equation of normal of the slope 4/3 and, right, this is the circle, this is the circle. Circle is x square plus y square is equal to 9. Slide once again. Which slide, beta? This one. Janu Bilari, this one. Equation of normal. I said equation of normal. Okay. So what I said is, if you have to find the equation of normal, so first of all you need what is a normal. Okay. Normal is a line which is perpendicular to the tangent at the point of tangency. Okay. So now one note I gave you that any normal to the circle will always passes through the center of circle. Okay. So now if I want to know a line which is normal, that is passing through the point x1 comma y1 and perpendicular to the tangent, I can write down easily. But I also have one information that line, this line will also passes through the slope. This line will also passes through the center of circle. which is minus g comma minus f. So now this question is reduced to find the equation of line passing through the 2 point x1 comma y1 and the and minus g comma minus f. So simply y minus y1 is equal to slope x minus x1. Clear? Or you can say that, or alternatively you can say that equation of normal is y minus y1 is equal to slope of normal into x minus x1. And what is slope of normal? Which is nothing but negative time reciprocal of slope of tangent, x minus x1. Okay. Anyway, these all are true. Okay. Y minus y1 is equal to slope of normal into x minus x1. And what is slope of normal? Minus time 1 upon this. Okay. This is for slope of normal. Slope of normal. N is for normal and T is for tangent. Is this clear now? Janvi Balari, is this clear? Okay. So where we were? Yeah, on this question. Okay. Find the equation of normal of the slope 4, 3 to this circle. Okay. So let's say let's say this is normal. Okay. Let's say this is a normal. So clearly normal will passes through the center of the circle. Always, I have told you, any normal will always pass through the center of circle. And this normal, this line has a slope 4/3. So you can say that normal has slope 4/3 and passes through center. Passes through center, which is 0, 0. So equation of normal is y minus y1 is equal to slope x minus x1. So 3y is equal to 4x. So 4x minus 3y is equal to 0. Is this clear, students? Students, tell me quickly in the chat box. Is this clear? So equation of normal अब समझ में आ गया कैसे निकालेंगे? Is there any doubt, students? Tell me in the chat box if you have any doubt regarding this. Any doubts? Clear? So slope pata hai, and one information we know that the normal will always passes through the center of circle. So slope pata hai, point pata hai, equation of normal is very easy now. Okay. Okay. So now if it is clear, then shall we proceed further? Okay, very good. So let's move on to the next question. Okay, this question is saying that tangent to the circle x square plus y square equal to 5 at this point also touches this circle. Find the coordinate of the corresponding point of contact. It means, first of all, 1, minus 2 is clearly lying on the circle x square plus y square equal to 5, right? So let's say this is a circle. Let's say this is a circle. This is circle S, which is x square plus y square is equal to 5. So its center is 1, minus 2. Okay, its center is 1, minus 2. So let's say this is the point. Let's say this is a point P, which is 1, minus 2. Sorry, center is 0, 0. 1 second. Let me just write this down again. So let's say this is a circle. X square plus y square is equal to 5. So let's say this is some point P, which is 1, minus 2. Okay. And clearly the center of circle is 0, g. Clear? Clear? So this question is saying that tangent to the circle, this circle also touches the circle x square plus y square minus 8x plus 6y plus 20 is equal to 0. Okay. Means this circle x square plus y square minus 8x plus 6y plus 20 is equal to 0. Okay. So now let's say this is the circle. Let's say this is some circle. Let's say this is the circle. Okay, doesn't matter. Okay, doesn't matter. Circle क्या है? मान लो ये circle है. So question is saying that if I draw a tangent, let's say if I draw, let's say just to make sure that we got it right. Okay. So let's say let's say circle, if I draw a tangent on the circle x square plus y square is equal to 5. Okay. So it is saying that circle passes through the point circle. This tangent is also the tangent to this circle. Okay. So let's say this is the circle. This is question saying. So this circle has clearly center 4 comma minus 3. Okay. So question is asking us to find this point A, this point of contact. Question समझ में आया? Everyone. Question is saying that a tangent is drawn to this circle x square plus y square equal to 5 at this point P 1 comma minus 2, and when I extend the tangent, this tangent is also the tangent to the circle y my this circle x square plus y square minus 8x plus 6y plus 20 equal to 0. So now find the point A. That's all. Is this clear, everyone? Is this clear? The question is clear? Okay. So let's say, so this is a tangent. So first of all, what would be the equation of tangent? What would be the equation of tangent? Clearly, that point P is lying on the circle x square plus y square equal to 5. So equation of tangent can be given by using the transformation. X1 plus y1 is equal to 5. So x minus 2y is equal to 5. So this is the equation of tangent. Equation of tangent. Is that clear? But question is asking that this tangent is also the tangent to this circle in yellow. So find the point of that contact A. So now can anybody tell me how should we proceed? How you are going to find the point of contact? Yes, one method. Yes, one method is absolutely one method is, let's say this point is x1 comma y1, and write down the equation of the tangent, and that equation of tangent and this equation of tangent is identical. Then compare the coefficient and do that. Okay, that is yes, one of the method for sure. Is there any shortcut method? Like any other method? Okay. So one method is that clearly if I draw the normal on this circle at point A, this normal will pass through the center. Yes or no? This is normal. Okay. What is the slope of tangent, students? Slope of tangent is, from this equation we can say that slope of tangent is half. So what would be the slope of normal? It implies slope of normal क्या होगा? Negative reciprocal of slope of tangent, which is minus 2. Okay. So equation of normal क्या आएगा? Now equation of normal at point A, at point A कितना आएगा? Slope पता है, and we know that the normal will passes through the center of circle also, right? Point पता है, slope पता है, equation we can find. Yes or no? So equation of normal कितना आ गया? What is center of the circle, student? 4 comma minus 3. Slope is minus 2. So 4 comma minus 3. So y minus y1 is equal to slope x minus x1. Is that clear? Is that clear? Y minus y1 is equal to slope x minus x1. So what is the equation of normal? Y plus 3 is equal to minus 2x plus 8. So 2x plus y is equal to 5. This is the equation of normal. Okay. So let's call this equation 1. Let's call the equation of tangent equation 1, and let's call the equation of normal equation 2. Okay. Now for point A, for point of contact, that is point A. Solve equation 1 and 2. That's all. What is equation 1? X minus 2y equal to 5. What is equation 2? 2x plus y equal to 5. So what you can do is equation 1 plus 2 into equation 2. That's all. Add these two equations. Just multiply equation 1. So equation 1 कितना है? X minus 2y equal to 5. And what is equation 2 after multiplying with 2? 4x plus 2y is equal to 10. Add कर दो. 5x is equal to 15. X is nothing but 3. X 3 आ गया. So now put in any of the form, any of this equation. So it implies y is nothing but put this, let's say put here. So what you will get? X is 3. So y is minus 1. So y is minus 1. Clear? Is that clear? So the point of contact कितना आ गया? So you can say that point of contact is 3 comma minus 1. Okay. Is that clear, students? Is that clear? क्या किया हमने? Okay, देखो कितना easily हो गया, right? Equation of question समझ में आया? Solution समझ में आया? कैसे किया हमने? How we have used the normal to get the point of contact, right? So you can do this also, okay? So if somebody asking you the point of contact and you know the slope, if you know the tangent, then just find the equation of normal and solve the normal and tangent to get the point of contact, okay? Or either you can use the transformation to find the equation of tangent and then use those two equations to get the point of contact. Is that clear? Any doubt, students? Janvi Ballari, Janvi Chitra Durga, is there any doubt? Everything is clear? Clear? Is there any doubt? Okay, very good. Shall we proceed further, students? Shall we proceed further? Okay. So now, students, now let's talk about the code of contact. Okay, in today's class, I'll just give you the brief introduction to the code of contact. In the next class, we are going to look into the problems on the code of contact. Okay. So see, student, the equation of tangency, condition of tangency, code of contact, and the topic that we will going to study in the further classes also. So those all topics are similar to the topic which we will be studying in the parabola, ellipse, hyperbola. Okay. So it's very, very important that you should learn the circle very well. Okay. Because if you have clear understanding in the circle, you can say that your other parts of the conic section, that is ellipse, hyperbola, parabola, is going to be really easy for you. Okay. Okay. Because the same concept will come in again and again, but the curve is different. So the equation will come different, but the concept will remain same. Okay. All the concept will remain same. Okay. So what is the code of contact? Code of contact is simply, let's say from a point P, x1 comma y1, and this point P is external point. Okay. This is the point P, x1 comma y1, which is lying outside of the circle. And as we know already that from this point P, two tangent can be drawn on the circle. So let's say the tangent PA and this tangent PB is drawn to the circle. Clear so far? So the point of contact of the tangent is A and B. Point of contact of this tangent is A and B. So the chord joining these 2 points A and B, this chord, the chord joining this 2 points A and B is nothing but the code of contact. So the chord AB joining the point of contact A and B to the tangent from the point P is called the code of contact P x1 comma y1. Okay, with respect to circle. Is that clear? Is that clear, students? Tell me, is that clear or not? Clear? So what is the equation of code of contact? Is given as t is equal to 0. What is t is equal to 0? It means, this means assume point P, which is x1 comma y1, is lying on circle and write down the equation of tangent using transformation. Okay, using transformation. That's it. So see, you just assume that the point P is lying on the x1 on the circle. Just write the equation of tangent, but the point is not lying on the circle. So whatever we find using the transformation will not give you the tangent equation. Yes or no? Because the point is not lying on the circle. So what would that give you? That will give you the chord of contact equation. Is that clear? Is that clear? So equation of chord of contact समझ में आया? What is the chord of contact? Is that clear? So let's say from a point P, you have drawn a two tangent, okay, and those two tangent touches your our circle at point A and B. Okay, this two tangent touches our circle at point A and B. 1 second. Okay, yeah. So these two tangent touches our circle at point A and B. So a equation of a chord which is joining A and B point is given as t is equal to 0. And what is t equal to 0? Assume the point is lying on the circle, write down the equation of tangent using the transformation, but point is not lying on the circle, so it will not give you the equation of tangent. What it will give you? The equation of chord of contact. Clear? Is that clear? So for example, for the generalization purpose, let's say this is the center minus g comma minus f for the circle x square plus y square plus 2gx plus 2f5 plus c is equal to 0, and this is the point, let's say x1 comma y1. Okay, so let's say this. Okay, let's say this, from this point P we have drawn two tangents and they are passing through the their point of contact is AB. So the equation of AB would be, so equation of AB is t is equal to 0. This is just the notation. Okay, you should always remember the notation. So equation of chord of contact is t equal to 0. What is t equal to 0? Assume the point P is lying on the circle. Find the equation of tangent using transformation, but the point is not lying on the circle, so it will not give you the equation of tangent. In that case, what it will give you? The equation of chord of contact. Simple as that. Okay, so equation of AB is t equal to 0. That is x1 plus x1. So equation of tangent क्या आएगा? x1 plus y1 plus g into 2x is x plus x1 plus f times 2y is y plus y1 plus c is equal to 0. So this is the equation of chord of contact. Equation of chord of contact. Is that clear, students? Students, is that clear? Is that clear? Tell me. Do you have any doubt regarding this? Do you have any doubt regarding this? Okay. So see, so one might think how it will come. Okay, you just have to directly remember this. Okay, there is no need to you see the derivation. How did it come? Because it's irrelevant. Or you can think like that. See, from this point x1 comma y1, you can find the equation of two tangent A. This equation PA and PB. Slope of you can find the equation of tangent easily. Just now we have seen how to find the equation of tangent if the point is lying outside the circle, right? So let's suppose we have find the equation of tangent. Okay, so individually we can find this point of contact, this point of contact. Yes or no? Just first assume this point is x1 comma y1. Write down the equation of tangent. Okay, so then compare that tangent with this tangent, get this point. Similarly, compare this tangent with the tangent that you have assumed if the point is lying on the circle. So compare that point, that tangent. So the point A and B has come. 2 point come, the slope of tangent, the slope then the equation of AB can be easily found. Yes or no? So that is very lengthy process. Okay. So you have to just remember the result, that equation of chord of contact can be given as T is equal to 0. What is T equal to 0? As write down the equation of tangent, assuming the point P is lying on the circle, but point P is not on the circle. So it will not give you the equation of tangent. In that case, what it will give you? It will give you the equation of chord of contact. Is that clear? Tell me quickly in the chat box how many of you understand the chord of contact. The definition of the chord of contact is clear, and the equation of the chord of contact. Any doubt, students? Tell me quickly in the chat box. Clear, everyone? Okay, very good, very good. So let's see one small question. Okay, one small question on it. So question is saying that equation of chord of contact of the tangent drawn from this point 2 comma minus 3 on to the circle x square plus y square plus 4x minus 6y minus 12 is equal to 0. Okay, so this is a circle x square plus y square plus 4x minus 6y minus 12 is equal to 0. Okay, so let's say this is the circle x square plus y square plus 4x minus 6y minus 12 is equal to 0. When you put this point in the circle, you will see that s1 is greater than 0. So this point is lying outside the circle. Okay, let's say this is the point P. So they are asking you to find the equation of chord of contact. So let's say one tangent is like this and one tangent is like this. So they are asking us to find the equation of chord of contact, that is find the equation of A and B, this line. So how you will find equation of chord of contact, that is equation of AB is T is equal to 0, which means assume this point 2 comma minus 3 is lying on the circle and write down the equation of tangent x x1 plus y into y1 plus 2 times 2x x plus x1 2y minus 3 कॉमन, सो 2y को क्या लिख सकते हैं y प्लस y1 माइनस 12 इज इक्वल टू 0. कितना आ गया ये 2x माइनस 3y प्लस 2x प्लस 4 माइनस 3y प्लस 6 माइनस 12 is equal to 0. So this is 4x minus 6y, 4x minus 6y plus 4 plus 6 plus 10 minus 12 minus is equal to 0. So this is the equation of chord of contact. Chord of contact AB. Is that clear, students? Is that clear, everyone? Tell me quickly in the chat box. How many of you understand? Is that clear? Okay. So now that's all for today, students. But one very important homework is that you have to verify. You have to verify. So I'm writing the method 2 that you have to verify. Okay. Method 2 is verify the equation of chord of contact. कैसे करोगे verify? I'm just telling you which step you have to follow. Find equation of tangent, that is PA and PB. Okay, point is lying outside the circle, so you can find the equation of tangent. That the method I have told you. Okay, then find the point of contact A and B. Okay, then find equation of AB. Is that clear, students? Is that clear? So these things you have to do. Okay, verify the equation of chord of contact. कैसे verify करोगे? First find the equation of tangent PA PB, then find the equation point of contact A and B, then find the equation AB, and you will verify and you will see that this is the same equation you will get. Okay, 4x minus 6y minus 2 equal to 0. Is that clear, everyone? Is that clear? Okay, very good, very good, very good, student. So that's all for today, everyone. Okay, see you in the next class. So this is the homework question. Okay, write down the homework question, everyone. Write down the homework question. Okay, and verify this. Verify the point of contact equation. Okay, that is very important. You will get the practice. Okay, you will get the practice of the writing the equation of tangent if the point is lying outside the circle. Then how to find the code of point of contact. Okay, so this is a very quite important questions. Okay, so many things you are doing in the same thing. Okay, so that's all for today, everyone. See you in the next class. Okay, bye everyone. Bye Anantan. Bye. Thank you everyone. Okay. Bye.